At the point like this is insects, depending on how thick they are. You can either use diascopic from the bottom or episcopic, which is from the top. Mine's just going crazy. Right. There we go. So this guy's thin enough that the light goes through and refracts off the parts of his body. Okay. We're going to skip over field of view because I want to try and get some fun stuff in before you have to go. But I'm going to record these field of views and come back to it. So if you want to flip to resolution, right, couple in, field of view, plants, and resolution. Resolution is being able to distinguish two parts from each other. So if you have a high resolution television, you get a lot of detail in it. Magnification is cool because it can make things pop. It can bring things like really close to you, but it doesn't mean that you can always see things clearly. Because you can magnify things, we get a blurry image, knowing it's bigger, but resolution is really what helps you to distinguish one point from another, two separate things apart. So in your envelope that says 102, you should have a penny. This. I'm guessing you've all seen a penny before. But we're going to look at it a little bit different. So let's take out the B, drop them back into the slide case. Close my slides. And we're going to explore the penny and see what we can resolve this. So penny you don't need, it's big enough that you don't need a slide to go on here. And slide it on and put over the light. Obviously, we're not going to be able to project from the bottom because it's metal is going to block it all. Let's see what we can do. Scanning, top lit. Ooh, mine's kind of crusty. I can see the edge. Words. So there's resolution. Just being able to see that fine edge. If you get more resolution, you can see more of the like 3-dimension drop off to it. Anybody know what that word is? RTY at the end of it. Liberty. Scan around. You've probably seen pennies lots and lots of times. You haven't thought about it. Anybody know how many penny or how many times Lincoln appears on the penny? Your penny has a cut in it. What's your penny made out of? Something tore it. You can tell by scratch marks. It looks silver on the inside, not coppery. Because after 1982, your penny is more zinc than copper. Because the government decided to take a break on taxes and put cheaper stuff in the pennies. Oh wait, no, they didn't take a break on taxes. They kept going up. I was wrong. I was mistaken. Right, there you can see a nose. So there's definitely one Lincoln. His mouth, beard. Ooh, the ear. I've been moving with my fingers. Let's see if I can get my fingers on here. And you already know that the image is flipped, so oops, 2000. Huh. Doesn't want me to know. Can't seem to find another Lincoln. So I'll flip it over, explore. Anybody know what the building is on the back of the penny? Give you a hint, it's not the Washington Monument. There we go, States. Pretty decent resolving power, even with my autofocus on. Check out that building. So coin collectors can look at a coin and see if anybody's cleaned it before to make it shiny, to try and bring back its value, but it leaves marks all over it. Clearly nobody's tried to clean this penny. Super filthy. So can you see that? I'm just scanning along that building on the back, and there's the other Lincoln. A lot of light. Down a little bit. Oh, that made it worse. He's just chilling back there. Did you know that was back there?
No, I had no idea.
See the fun things you find when you play with a microscope and have nothing better to do? Oh, I thought, should I give them little circuit boards to look at and show resolution? Because this is great for working on electronics. I thought, what's something they see every day and they probably never pay attention to? Actually, I don't even remember the last time I had a penny in my pocket. I shouldn't say that. It's been a while. But yeah, there's a second Lincoln right in the middle of the Lincoln Monument on the back side. Boom. I totally want to get this one last thing in. Just one more. Because I want you to see how cool the glasses are. So if you grab the sand, resolution is all about being able to distinguish 2 points. If you go to the metals page on the next one, we did the exploring the penny. But anybody want to guess what that thing is? It's actually, and there's one in here, tip of a safety pen under your microscope. So you can explore and look at that. Things you usually don't pay attention to the detail of. Oops. And that's only 40 times magnified. Wow, this one looks way more menacing than the other one. It's like some Star Trek-y weapon. Okay, sand on traction. So let's take a note card. There's a note card with the new envelope too. Should have a bunch of extra ones. We'll make it the other way so we don't spill by pushing a pencil through it. This is the last one. So we're going to make this business card slide through. Push all the edges down. Just want to run up round sample. Push, 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 push. Little piece of tape. we can get it off. There we go. And I'll take the probe, rip the tape. Maybe, where'd my probe go? In the envelope, there's a plastic knife. I'll have it back up. The Boy Scout. So I made a little slide card again. Tape on the bottom. Smooth side. Here's a catch-all. And a little packet of sand and some seashells. It's a little mini vacation right in your kitchen. I'm going to take a little bit of the sand, not a lot. Put right in the hole. I don't want multiple layers. I want to try and spread each of those pieces of sand out just a little bit. Oops. Slide under the scope. Ooh, cardstock. I didn't think of that to look at. It's paper. You can definitely see it's thicker than the papers we looked at earlier. This way. Going, going, going. Oh, there we go. Oh, my scanning is really doing a great job. It's almost like it's a 20x, not 10x up here. Cool. Nice white sand. All of this is quartz. It's a mineral. It's not rocks. Now let's see if it's going to work. I have a feeling I know why it didn't work last time. So if we take our polarizing glasses, put one underneath, put one above, we turn it slowly. Yep, I know what happened. So you kind of see flickers of color happening. What happened is that things that are clear bounce light. So I just happen to have a glass slide that doesn't have tape on it. I'm gonna put a little bit of that sand on the glass slide. There you go. You won't be able to do this. Maybe if I can find my sand. Back to the back where it belongs. Doesn't seem like me. Sure didn't. Bugs. Glasses. Floss. Where's my brain here? Sand. Lost my sand down here too.
On the desk.
I swear.
On the desk.
Oh, guess that. Thank you. Okay. I wasn't sure if I'd run out, so I got a lot. So sprinkle a little bit of the sand. Oh, I sat the sand right on my old sand. Okay, get the excess off. It's just sand. I'll clean it up later. Okay, going under. there. So pretty. You can see how crystal clear it is. Now, if I put the light bending underneath and on top, uh-oh, what's going on with you? You can kind of see right where the bends are. Change a little bit of color. See the purple kind of coming out. I'll try some others. I'll just scooch it down. Give these a shot. As they say, when science gives you lemons, you're in the wrong field. Yeah. Walnuts. It's just one of those days with the microscope. So it's trying to change colors, and I think my autofocus is going crazy on me. Yep. Walnuts. And out of time too. So we'll be opening up the new packets. I'm going to put together the pieces that we're missing here. So if you get a chance and you want to come back and play, you can go through that. You can look at field of view and how to measure things in the microscope. You can learn about filters, the red and the blue that you have, how to do simple wells, and then I will make this thing work and get back to you too. So thanks for playing today. Have a good weekend, and I'll talk to you soon. If you have any questions, get a hold of me. Thank you.